Every organization running on Snowflake faces the same challenge: understanding where compute spend goes, why queries slow down, and how to optimize without guesswork. Most platform teams would agree. Snowflake adoption is incredible for innovation, but with growth comes cost pressure. Leadership wants to see efficiency. Engineering teams want autonomy. And someone needs to bridge those goals without hiring consultants or launching multi-week manual investigations. Apex Query is a Snowflake compute intelligence application that transforms raw account usage data into clear, prioritized, actionable insight. No external infrastructure. No data leaving your account. It deploys as a native app directly inside Snowflake and connects to the telemetry you already have. Whether you're overseeing a well-established enterprise Snowflake platform or just beginning your onboarding journey, Apex Query is a valuable tool. In fact, early in platform adoption is the best time to introduce Apex Query to your engineering teams. Rather than waiting for cost to become a concern requiring attention and remediation, teams can incorporate best practices and guidance early in their implementations, ensuring a smooth and efficient ramp-up in Snowflake adoption, avoiding cost concerns before they accumulate. Let me walk you through the application. When you first open Apex Query, notice the layout. At the top, you'll see the application header with two radio button mode selectors: Warehouse Efficiency and Query Intelligence. These represent fundamentally different compute surfaces that each deserve focused analysis. Selecting one changes the row of radio button tabs below it, giving you targeted views for that mode. On the left side, the Filters sidebar provides your global controls. At the top is the Look Back window slider, ranging from 1 to 90 days. This controls how much historical data feeds every dashboard. Below that, the Activity Scope radio buttons let you toggle between warehouses and serverless tasks, two separate billing dimensions. Then you'll see a multi-select warehouse filter to scope your analysis to exactly the warehouses or databases you care about. One more thing on the sidebar. Notice the automated Deep Assessment button at the bottom left. We'll come back to that. It's one of the most powerful features in the entire application. And every single tab in this application includes a guide button in the upper right corner. Click it, and you'll get contextual guidance, the tab's purpose, key insights to look for, considerations to keep in mind, and specific actions you can take, including ready-to-use SQL commands. This means your team can self-serve without needing training or documentation. Let's start with Warehouse Efficiency mode. The Overview tab is your landing page. A sortable inventory table shows every warehouse along with its workload type classification, size, generation, total credits consumed, and query count for the selected period. Below that, a horizontal bar chart ranks warehouses by the metric you choose, whether that's credit spend, query volume, or total execution time. Within seconds, you can identify which warehouses deserve deeper investigation. In this environment, notice that the Customer 360 warehouse is consuming over 1,100 credits while the ETL pipeline warehouse is running over 25,000 queries. Those are two very different optimization conversations, and Apex Query surfaces them instantly. Moving to the Warehouse Compute tab. Here we see time series credit consumption broken down over time. This view answers the fundamental question: how is spend trending, and where are the spikes? You can quickly identify unexpected surges, correlate them with deployment events, or spot steady growth patterns that warrant attention before the next invoice arrives. Now the Warehouse Load tab. This visualizes queuing and load distribution to identify contention and capacity constraints. High queuing means the warehouse is undersized or the workload needs redistribution. Sustained high load tells you it's time to scale up or enable multi-cluster. Brief spikes during batch starts are normal, but persistent queuing during business hours degrades your user's experience. The Idle and Suspend tab is where cost savings become tangible and immediate. This is one of the most revealing views in the application. It analyzes gaps between queries and quantifies credit waste from warehouses sitting idle before they auto-suspend. Look at the metrics: total idle credits wasted, average waste percentage, peak thrash warehouse, and median query gap. The credit waste chart immediately shows which warehouses are burning the most money while doing nothing. The gap distribution chart tells you whether it's safe to suspend aggressively or whether you risk resume thrashing. And the hourly idle trend reveals exactly when the waste occurs. In many organizations, 5 to 15% of total compute spend is simply idle waste, recoverable without changing a single workload. Next, the Sessions tab. This one tells a powerful story about orchestration. So let me demonstrate. The Sessions tab visualizes concurrent session activity as a Gantt-style timeline, revealing exactly when sessions start, how long they run, and how they overlap. You can color by user, warehouse, or role. But what's worth highlighting here is how this visualization exposes a scheduling pattern that costs real money. I'm going to clear the warehouse filter on the left and select just two warehouses, ETL pipeline and ETL parallel. These two warehouses execute nearly identical workloads, the same queries, the same data volumes. The only difference is how the sessions are orchestrated. Let me zoom into a batch window on ETL pipeline first. Notice the pattern. Sessions are staggered and overlapping. One starts, then the next one kicks off, then the next, as the first completes others are still active. They overlap, keeping the warehouse active from the start of the first session all the way through the end of the last session in the batch. The warehouse doesn't suspend until the last session completes plus the length of auto-suspend timeout. It's burning credits the entire time, longer than required for the workloads. Now let me zoom into the same batch window on the ETL parallel warehouse. Look at the difference. All sessions initiate simultaneously. They execute in parallel, finish together, and the warehouse suspends after the completion of the longest running session. The difference is the longest running session was initiated immediately, minimizing the total execution time off batch. The total active window is a fraction of what we saw in the staggered warehouse. Same queries, same data, dramatically fewer compute units consumed. Let me navigate back to the Overview tab to quantify this. With only these two warehouses selected, look at the credit consumption. ETL pipeline, the staggered orchestration, is consuming roughly 3 times the credits of ETL parallel. 3 times the cost for the same work, because the sessions were staggered and overlapping instead of synchronized to run in parallel. This is the kind of insight that pays for itself immediately. No warehouse resizing needed. No query rewriting. Just an orchestration adjustment, a scheduling change, and you recover 2/3 of that compute spend. Apex query surfaces findings that would otherwise require hours of manual investigation. The sessions timeline made this pattern visible in seconds. Now let me reset the warehouse filter to view all warehouses again, and continue on to the right-sizing tab. The right-sizing tab focuses on a different class of waste. Warehouses that are either too small, causing expensive disk spill, or too large for their workload. Key performance indicators show total spill volume in gigabytes, the percentage of queries experiencing spill, and the slowdown factor. A scatter plot maps warehouse size against spill severity, and a stacked bar chart separates local from remote spill, because remote spill is orders of magnitude more expensive. The tab produces concrete sizing recommendations grounded in actual workload behavior, not rules of thumb. The caching tab evaluates cache utilization. Color-coded indicators flag warehouses with poor cache hit rates, below 50%, alongside a performance gap metric that quantifies how much faster queries could run with better cache utilization. This often reveals opportunities to restructure scheduling or adjust suspend timers to keep working sets warm. And the Query Queuing tab. A heat map of queuing pressure by day of week and hour of day. This immediately reveals scheduling hotspots, those Monday morning batch runs or end-of-month contention windows. The data supports informed decisions about load distribution, scheduling adjustments, or targeted scaling. And remember, rescheduling is free. Upsizing costs credits. Now let's switch to Query Intelligence mode. The Query Types tab breaks down execution by statement type. Select, insert, merge, create, and others. This structural view often reveals surprising patterns, like copy operations consuming more credits than analytical workloads, or DDL storms from poorly configured deployment pipelines. The Query Patterns tab is where things get powerful. It identifies your top query patterns by parameterized hash, grouping identical queries that differ only in literal values. This is critical because a single inefficient pattern executed thousands of times per day can dwarf the cost of any individual query. The tab attributes total credits, execution time, and frequency to each pattern. In this environment, the top 3 patterns alone account for the majority of compute time. Optimizing those 3 gives you 80% of the performance gain. Drilling deeper, the Query Details tab. This shows individual executions within a selected pattern, with statistical anomaly detection. Using z-score analysis, it flags executions that deviate significantly from their pattern's historical norm. The query that usually takes 2 seconds but suddenly ran for 40. These anomalies often indicate data skew changes, missing pruning, or concurrency issues. And now, the Pattern Optimizer. This is where analysis meets query tuning. Select any high-impact query pattern, click Optimize Pattern, and the application analyzes the SQL structure and produces an optimized rewrite. The output includes rewritten SQL that your engineering team can copy and test immediately, along with a plain language explanation of what was changed and why it improves performance. Beyond the rewrite, Apex Query provides ready-to-execute SQL commands to inspect the query's explain plan and review existing clustering indexes on the source tables. If optimized clustering keys would improve partition pruning, the application provides the exact alter table statements to implement them. Everything is laid out so your team can validate, test, and apply changes on their own terms. These are production-ready optimizations grounded in how Snowflake actually executes queries against your data. Now let's switch the activity scope to serverless tasks. The Serverless Overview tab summarizes task compute across your account. Key metrics include total serverless credits, run count, active task count, and success rate. A horizontal bar chart ranks databases by task credit consumption. In environments with hundreds of scheduled tasks, this is the only way to quickly identify which pipelines are driving cost. The Task Compute tab provides per-task credit breakdown. Credit consumption over time reveals cost spikes and trends. Credits per run varies by task complexity and data volume. Compare similar tasks to find outliers. Duration metrics help identify tasks that may benefit from query optimization. The Task Execution tab tracks execution states over time. Succeeded, failed, canceled, skipped. High failure rates indicate instability. Skip tasks cascade from predecessor failures in a DAG, amplifying impact. This view gives you pipeline health at a glance. The Task Failures tab provides detailed failure analysis. Rather than scanning logs manually, this view aggregates failure patterns, surfaces recurring error codes, and helps teams prioritize reliability improvements. Tasks with greater than 10% failure rate waste credits on failed compute and should be addressed immediately. And the Task DAG tab maps the dependency structure of your serverless pipelines. It shows how many DAGs exist, their total credit footprint, average depth, and total run count. A cost ranking chart identifies your most expensive pipelines. The critical path duration identifies the bottleneck for end-to-end completion time. This helps teams understand the blast radius of any single task failure or optimization opportunity. Now, let me show you the feature that ties everything together. The Automated Deep Assessment. That button on the sidebar. Click it, and Apex Query runs a comprehensive rule-based evaluation across all selected warehouses or serverless databases simultaneously. It checks for idle and suspend inefficiency, right-sizing issues, cache underutilization, scaling misconfigurations, query acceleration service eligibility, queuing pressure, and query pattern waste. It even analyzes your most expensive query patterns and produces optimized rewrites automatically. The output is a prioritized list of findings. Each one is tagged with severity, critical, high, medium, low, or informational, and includes an estimated credit impact. A master grid lets you drill into any warehouse or database to see its specific findings. Expand any finding to see the current state, the recommendation, time impact, and confidence level. Think of it as an automated consultant that runs in seconds and surfaces the 20% of changes that will recover 80% of wasted spend. No guesswork, no multi-week engagement, just data-driven prioritization. Let me step back and tell you why this matters. Enterprise Snowflake platforms routinely accumulate 20 to 40% in avoidable compute costs. Idle warehouses, unoptimized query patterns, and unchecked serverless tasks compound silently. Before Apex Query, finding these issues required senior engineers spending days writing custom queries against account usage views, manually correlating patterns, and building one-off reports that went stale the moment they were produced. Now, any team member can open this application, select a look-back window, filter to their warehouses, and within minutes have a complete picture of where credits are being wasted and what to do about it. The guide buttons mean they don't need to be optimization experts. The deep assessment means they don't need to check each tab manually. And the pattern optimizer means they can fix expensive queries without waiting for a database administrator. Apex Query deploys as a native app directly in your Snowflake account. It requires no external infrastructure, no data movement, and works with the usage data you already have. Whether you're a platform engineer tuning warehouse configurations, a FinOps analyst tracking compute trends, or a data engineer optimizing pipeline costs, Apex Query shows you exactly where to act. This is compute intelligence, made practical. This is Apex Query. Get started today. Search for Apex Query on the Snowflake Marketplace, or visit apexquery.pro to learn more.